Hey, this is Corey Hatfield. I'm doing sets and properties today, specifically the number system. This is the standard Kentucky High School N3 under the cluster use properties of rational and irrational numbers. I always start my class with a joke or a riddle or some type of question. And this one is, would you rather have super speed, be able to fly, be able to teleport? Why that choice? The whole point is to get them thinking, to get them talking, and to get them into class and into a right mindset. Then we move on to a quick warm up, which in this one, we're just going to talk about what a Venn diagram is, what do the parts overlap, and I throw at them a bunch of different Venn diagrams just to get them thinking about that so that we can then get into real, rational, integer, whole, natural, and irrational. Now, I give them all of these examples. I do not tell them what any of the definitions is. And the reason I did that this year was because I didn't like just giving them definitions and them trying to memorize it. They tend to forget it completely. This time I was trying to get them to think about it, to create their own definition, and really get them involved in the process making. So I gave them a bunch of examples of each type. Before I let them go, I just made sure that they understood the fact that natural is completely inside of whole. So every natural number is also a whole number. I also made sure they understood the fact that rational and irrational are separate, meaning there's no overlapping. I then had them discuss in their groups, what do each word mean? And then I gave them a sheet, a handout, where they had to come up with their own examples. So it's a completely blank version of that exact Venn diagram there. And they had to come up with their own examples and write them down. Inside the examples on the right, I had them actually write their definition out. And then the letter was just to get them to not have to write out the word every single time. After they came up with their own examples, their definitions, we debriefed. We made sure that everyone understood what each thing was. During their discussion, I walked around and I checked in with each group and asked them a different set to see what they came up with. That way, when I came to the debrief, I could ask a specific group, well, what did you come up with this set? Afterwards, we do some practice questions. The whole point of the examples that I had were that some of them weren't simplified. So they had to realize you have to simplify first, then you can name the sets. And we did one example together, and then I let them finish that page. This took about 25 to 30 minutes because the conversations were really good, and I didn't want to stop them. Once I felt like everybody understood it, people were checking their answers, so I knew that they were getting done. We then moved to the back of our page, which was properties. And again, I didn't want to tell them the property so that they'll forget it. So I just gave them examples of each type of property, and I asked them to again define them in each of their groups of what the properties were doing. I also made sure that they understood during this time the identity property and inverse property. There's a difference between addition versus multiplication, so make sure you're paying attention for that. Commutative and associative are closely related, so make sure you're comparing and contrasting. Once I got those guidelines down, I let them talk about it. And then again, we debriefed. We spent a little bit less time on this because we understood how we were discussing. And that then ended up here with our addition example, multiplication example. I let them choose whether they wanted to do an example in numbers or write a definition. Whatever helped them memorize that a little bit better was what I had them do. And then there was name that property portion. So they then utilize what we just discussed to practice that. Finally, it takes it a little bit step further with the additive versus multiplicative inverse. Using our properties, they had to actually transfer their knowledge and apply it. And then finally, I had a closure property on there just so that they saw something new, something we didn't talk about, and they had to figure out what that meant. The definition is there. They just had to understand it and then go even further, do true, false, or counter example. Most of these things came from All Things Algebra. I really liked their format and a lot of their questions, so I pulled that. But I didn't necessarily like how the notes were set up, and that is why I came up with this lesson for them to create their own definitions. But that was properties and sets, and hopefully you get a lot out of that.